here central difference. So here when you have x is equal intervals or equidistant, then only you can apply central difference. So which are the methods we will apply for equal intervals? Newton forward, backward, and here central difference. But in central difference you will get 4 methods. So first one is Gauss forward interpolation formula. Second one is Gauss backward interpolation formula, and third one is Stirling's formula. Fourth one is Basel's formula. So here when the given set of odd data means here 0, 1, 2, 3, 4. So 1, 2, 3, 4, 5, they given 5 set of data means odd data. Here y values is 2, 6, 8, 10, 12. Now we have to find out the middle value. So middle value is what I get 2. Suppose if they ask to find out f of 2.2 or f of 2.5 or f of 1.9. So these all values comes in near to 2 only. It is near to 2 only. So here when you're taking x naught for this one and xn for this one. So if it is near to x naught value, finding the values here. If it is near to x naught value, you are applying forward. It is near to xn means you are applying backward. But here it is nearer to middle values only. So if we get in middle values only means you have to apply central difference. Now so here they will only mention use Gauss forward method, find out f of 0.2 in the given set of data here. Okay, now here the given set of data here odd data. Now if they given even data, what happens? So if we get even number of data in columns 0, y values is 2, and from 4, and for 2 it is 6, and for 3 it is 8, and for 4 it is 10, and for 5 it is 12. 1, 2, 3, 4, 5, 6. Here even number of data. Then you have to find out the middle value. So what you get here, these two are the middle values. Now here first in this table first element is if you take it this one as x naught, you have to use for Gauss forward and Basel's. You have to take x naught as for Gauss forward and Basel's. So here for this one, if you take it for second one, you have to use for Gauss backward and Stirling's formula. Here first term, here first element, here first in middle of the table first element you have to use x naught for Gauss forward and Basel's, and second term for Gauss backward and Stirling formula. So you have to remember this one. This is x naught for Gauss backward and Stirling's formula. We are constructing forward table as here x and here y. So x naught, x1, x2, x3, x4, and here y0, y1, y2, y3, y4 up to x to the power of n. They are taking, just are taking example for this one. So here first difference they called as small delta. So to take these two difference means delta y, here 1 plus 0 divided by 2, 1 plus 0 divided by 2, so we'll get 1 by 2, so y suffix 1 by 2. And here delta y suffix 2 plus 1 divided by 2, so we'll get 3 by 2, means 2 plus 1 divided by 2, we get 3 by 2. We have to take average for these two. Average for these two suffix, only for suffix you have to take averages. So here what we get, delta y suffix 3 by 3 plus 5 by 2 will get, sorry, 3 plus 2, 5 by 2 will get. You have to take average. And delta y suffix you will get 7 by 2. Now delta, small delta square. So what you get, these two, delta square y suffix 3 by 2 plus 1, 3 by 2 plus 1 by 2 whole divided by 2. So you will get 1. So y suffix 1. And for these two, delta square y suffix here 3 by 2 plus 5 by 2 whole divided by 2. So what you get here? You'll get 2. So delta y suffix 2. Now these two difference, what you get? 5 by 2 plus 7 by 2 whole divided by 2. So you will get 3. So delta square y suffix 3 will get. Now delta cube. So what do you get for delta cube? These two difference, delta cube y suffix, what do you get? 3 by 2, and here delta cube y suffix 3 5 by 2 will get. 3 plus 2 5 by 2 here. You have to take average. Now what do you get? Delta to the power of 4. Delta to the power of 4. So what do you get? You have to take these two average. So delta to the power of 4, delta to the power of 4, y suffix, what do you get? 3 by 2 plus 5 by 2 whole divided by 2. So you will get 2. So delta y suffix 2. So this is the central difference table, but here for it is very difficult in problem. So for your convenient, we can use forward table or backward table. So I prefer go for forward table here. So how they will using forward table in central difference? So here x here, here I'll take x naught here, x suffix minus 1, x suffix minus 2, x suffix minus 3, so on, x suffix n. So x suffix 1, x suffix 2, x suffix 3, so on, x suffix n. Here in forward x0 to xn you are taking, but here in central difference you have to take for x suffix minus n to x suffix n. So if you add these two, you will get x suffix 2n. Remember that one up. So here now I will take y as y suffix minus n, so on, y suffix minus 3, y suffix minus 2, y suffix minus 1, y0, y1, y2, y3, so on, y suffix n. Now here delta y, I'll go for forward table, I'm not going for backward, I'm going for forward. So these two difference what you get, delta y suffix minus n will get. And these two difference, what do you get? What do you get? Delta y suffix minus 3. And these two difference, delta y suffix minus 2. Here, don't go for this method. I am going for forward elements here. What you get for forward elements, I am writing here. So what do you get here now? Delta y suffix minus 1, and these two difference, delta y suffix 0, and these two difference, delta y suffix 1, and these two difference, delta y suffix 2, and here you'll get delta y suffix 4. So what do you get? Delta y suffix 3, so on, delta y suffix n minus 1. Last term get eliminated here. So next here, delta square y. So what do you get? Delta square y suffix minus n. So on, what do you get? These two difference, delta square y suffix minus 3. These two difference, delta square y suffix minus 2. And these two difference, delta square y suffix minus 1. These two difference, delta square y suffix 0, and these two difference, delta square y suffix 1, and here these two difference, delta square y suffix 2, so on. What do you get? Delta square y suffix n minus 2. Last term get eliminated. So here, next delta cube y. So what do you get? Delta cube y suffix minus n you will get. So on, here you have to take these two, delta cube y suffix minus 3, take these two difference, delta cube y suffix minus 2, take these two difference, delta cube y suffix minus 1, and here if you go for this one, this minus this, delta cube y suffix 0 you will get, and here these two difference, delta cube y suffix 1, so on, you will get delta cube y suffix n minus 3. So here, delta to the power of 4 y. So what do you get? Delta to the power of 4 y suffix minus n, so on, delta. So on, here delta to the power of 4 y suffix minus 3, and here these two difference, delta to the power of 4 y suffix minus 2, and these two difference, delta to the power of 4 y suffix minus 1, and delta to the power of 4 y suffix 0, and here delta to the power of 4 y suffix 1 will get, so on. Last time we get delta to the power of 4 y suffix n minus 4 will get, and here delta to the power of 5, what do you get here? Check it. So what do you get? Delta to the power of 5 y suffix minus n, so on. What do you get? Delta to the power of 5 y suffix minus 3, and here these two differences, this one, and here these two differences, delta to the power of 5 y suffix minus 2, these two difference, delta to the power of 5 y suffix minus 1, these two difference, delta to the power of 5 y suffix 0, so on, delta to the power of 5 y suffix n minus 5. So up to where you have to write the construct the table. So up to here it is plus n2 minus n, will get difference is 2n will get, here n minus of minus n, so will get 2n. So up to difference will get 2n. So what do you get last year? Delta to the power of 2n y suffix minus n will get, y suffix minus n. So this is your this is even for central difference. table using forward difference table. So now how to write here. Now how to write the formula for Gauss forward interpolation formula, Gauss backward interpolation formula. I'll show using table. So first here Gauss forward, Gauss forward interpolation formula. So here y equals f of x equals f of x equals. So here which one is the central difference? Central difference is what I get? Middle of the table is x naught and y naught. So now here I take here for y naught, right? So here this is your central line. So this is your called as central line. So this is you called as central line. In central line always power should be even. So look at here y naught. In next one is delta square y naught, and next one is delta to the power of 4, and next is you will get delta to the power of 6. Another next one is delta to the power of 8, delta to the power of 10, 12, 14, like that it goes. So even central difference is always even power. So remember that one. Central line should be always even differences, and below that one you have to go for, you have to write here, you have to take the elements below the elements. So these are the elements you have to take below the central line. So now I will write the formula. Formula is what you get now here, what you get y naught plus what you get here r into what you get here, you go for y naught, come for downward here, downwards what you get delta y naught plus what you get, go for upward, so what you get r into r minus 1 divided by 2 factorial into what you get here delta square y suffix minus 1 plus again come for downwards, so what do you get r in r plus 1 into r minus 1, here r minus 1 again you have to take r plus 1, so divided by 3 factorial into what do you get delta q y suffix minus 1, and again go for upward, so what do you get here plus what do you get r plus 1 into r minus 1 into r minus 2 will take r minus 2 divided by 4 factorial into what you get delta to the power of 4 y suffix minus 2 plus what you get next year you have to come for downwards, so what do you get here r minus 1 r minus 2 will get, now you have to go for r plus 2 r plus 1 into r minus 1 into r minus 2 divided by what do you get 5 factorial into what do you get this one delta to the power of 5 y suffix minus 2 y suffix minus 2. So delta to the power of 5 y suffix minus 2 plus so on. It will be continuing. So you're using forward, right? Forward table, forward symbol also. So r equals x minus x naught divided by h. H should be equidistant. Remember, h should be equidistant. So now this is for Gauss forward interpolation formula. Now we have to go for backward. Gauss backward interpolation formula. So here, so Gauss forward you're taking for downwards. Below here, middle of this is your center line. Below the center line you are taking for Gauss forward. Now above the center line elements you have to take for backward. So above the center line means what you get here, this element, and come this side, and you have to go for this one, and here this element, and here to go for this one. So y equals f of x equals here y naught plus here to go for upward. Now what do you get? R into delta y suffix minus 1 plus here r into, so we'll get r plus 1. Start with r plus 1 divided by 2 factorial into delta square y suffix minus 1 plus r plus 1 into r into, we'll get r minus 1 divided by 3 factorial into delta cube y suffix minus 2 plus again you'll go for this one delta to the power of y suffix minus 2. So what do you get? R plus 2 into r plus 1 in r into r minus 1 divided by 4 factorial into delta to the power of 4 y suffix minus 2 plus we have to go for delta to the power of 5. So what do you get? Here r plus 2 into r plus 1 into r minus 1 is there. So what do you get? Next r minus 2 whole divided by 5 factorial into delta to the power of 5 y suffix minus 3. So on, where r equals x minus x naught divided by h. Stirling's formula. Stirling's formula. So here in Stirling's formula, here this is the central line. So you have to take here what are the odd differences there, delta to the power of 1, delta cube, delta to the power of 5, delta to the power of 7. So you have to take average for those two. Means here you have to take these two averages, and here these two averages, and these two averages. So what do you get now? Here y suffix r is equal to f of x equals what do you get? Now, so here y naught plus r into, you have to take average for these two, means delta y naught plus delta y suffix minus 1 whole divided by 2. So delta y suffix minus 1 plus delta y naught by 2, that is also no problem. Okay, you can write that one also. Plus some simplification, so we'll get r square divided by 2 factorial into average for this one, means we'll get same thing. So delta square y suffix minus 1 only will get, plus what you get, r into r square minus 1 divided by 3 factorial into, you have to take the average for these two. Average for these two means delta q y suffix minus 2 plus delta q y suffix minus 1 divided by 2. Otherwise I will write here, what do you get, r into r square minus 1 divided by 3 factorial into, what do you get, delta q y suffix minus 3 minus 2 plus delta q y suffix minus 1 whole divided by 2 plus r square into r square minus 1 divided by 4 factorial into, here we get delta to the power of 4 y suffix minus 2 plus so on. So where r equals x minus x naught divided by h. So now I take for bezels. So bezels formula. So here for Sterling's you're taking odd differences, right? So you're taking odd differences. Now here you're taking even differences. First take here to, you have to take these two averages, then you have to go for delta y naught, then you have to go for delta square y suffix naught. Here you have to take average, and then you have to go for delta q y suffix 1, then you have to go for delta to the power of 4 y suffix minus 2. So here you have to take average for these two, then you have to go for delta to the power of 5 y suffix minus 2. So like that you have to write the formula. So now Bezel's formula, what you get, you'll check it here now. So f of x equals, what you get, y naught plus y1 divided by 2 average for these two, plus r minus 1 by 2 into delta y naught plus here r into r minus 1 divided by 2 factorial into, what is it, delta square y suffix minus 1 plus delta square y naught whole divided by 2 plus here r minus 1 by 2 into r minus 1 whole divided by 3 factorial into delta q y suffix minus 1, then you have to go for average, r plus 1 into r minus 1 into r minus 2 whole divided by, you get 4 factorial into, you have to take average for this to delta to the power of 4 y suffix minus 2 plus delta of 4 y suffix minus 1 whole divided by 2 plus here r suffix r minus 1 by 2 into r plus 1 into r minus 1 into r minus 2 divided by 5 factorial into delta to the power of 5 y suffix minus 2. Let it take this one. So plus so on, where r equals x minus x naught divided by h.